This training module gives basic understanding of troubleshooting VACON 100 AC drive. This troubleshooting example is based on a customer case. This chapter is for customer problem and customer process overview. Customer calls to our technical support that drive is displaying faults randomly. They are able to reset the drive and run the application, but sometimes the faults occurs again. No information from customer side is possible to send via email, so service visit is arranged. Customer application overview is HVAC system fans at ice hockey arena. 2 VACON 100 drives are installed into the ventilation room. Both VACON 100 drives are running similar HVAC application. Both applications consist of motor, belt and fan. Drive frequency reference control is according to CO2 level. CO2 is increasing when people are coming to the arena. Higher the CO2 level is, faster the motor runs. This chapter is for collecting information. When starting to investigate drive, first thing to do is to download service info file and save it to the PC. Service info file can be loaded by removing the drive keypad and add communication cable to the same connector where keypad is installed. Service info contains parameters, fault history and 2 latest Datalogger files. In addition, the service info can be loaded by using normal Ethernet cable, by using the control unit Ethernet port. As a drawback, if using the normal Ethernet cable, the software upgrade is not possible to execute. Drive must be powered on when downloading the service info file. Drive can be powered by main supply, or by using the DC power supply directly to the DC main terminals by using nominal DC link voltage, or by powering the control unit with 24 volts external supply. Open the service info file, which is an offline file, and save to your PC. From the service info file, drive information can be seen. In the next slide is instruction how to see the drive information and rest of the service info file content. This is an overview of service info file. By clicking Drive Info, drive detailed information is available. Drive detailed information contains, for example, serial number, PCB numbers and software information. Service info file contains parameters of the drive and fault history. And 2 latest Datalogger files, Datalogger 1 and Datalogger 2. Fault history contains randomly undervoltage and overvoltage faults. Seems like undervoltage faults occurs always first. Can be seen that faults have been earlier resetted manually and then configured to auto-reset faults in history. This chapter is for troubleshooting. Troubleshooting starts after collecting the information. Process was operating when service personnel came to site. Since the process was operating, service person monitored the system to see how it is operating. Monitoring signals were added to the VACON Live PC tool. In this case, motor output current and voltage, frequency reference and output frequency, DC link voltage, motor output torque and motor regulator status were selected for the signals. Autoscale were used for scaling the minimum and maximum signals, as service person wanted to see is there any major fluctuation in signals. Rulers were added to monitoring screen and recorded time period for later reference. After monitoring the signals, conclusion was made that the process is operating normally. Troubleshooting contains also parameter inspection. Motor nameplate values were compared to the motor and those were correct. Noted that UF ratio is at default, linear, setting. Conclusion was made that ID run was not performed during commissioning. Service person performed ID run by selecting the at standstill method, as motor was coupled to the fan. ID run was performed to solve any future issues. No parameter setting found wrongly configured, which would cause the randomly seen fault codes. Since there have been fault codes called undervoltage and fault history, then the mains supply voltage level was measured. Undervoltage fault is DC link voltage level at low level. This is usually caused by missing mains supply. In this case, no issue found during measuring. This chapter is for understanding the link between fault code and Datalogger. Let's open Datalogger 1. By pressing metadata button from the Datalogger, information of the fault code can be seen. These information are drive name, software name, power module info, real-time clock time, if battery is installed, operation time which is drive internal time, sample rate, trigger type, fault codes. Operation time can be compared to fault history view also. This chapter instructs how to read Datalogger file. Open the Datalogger. In this example Datalogger 1. Check from the timestamp, which fault code this Datalogger is. In the beginning it is helpful to first remove the signals and look the values individually, one by one. Select the signals which you would like to see. For example, individual motor phase currents. Values can be zoomed in to see them more closely by clicking left from the mouse. By clicking right button from mouse, Datalogger can be zoomed out. If needed, scaling for phase currents should be same to see the individual phases in same scaling. In this example, DC link voltage is selected. DC link voltage is selected, as the fault history contains undervoltage faults. DC link voltage is scaled to start from 0 volts, to see full scale of DC link voltage. Motor regulator status signal is also selected, as this tells if some of the regulators have been active. Motor regulator status can be seen as binary. To see the individual bits, bit changes from 0 to 1, if some of the controllers is active. Activate the rulers from PC tool buttons. Left ruler in monitor view can be seen from the left ruler column, in bottom where the signals are. Right ruler in monitor shows the signals, in the right ruler column. Zoom into the fault problem occurring situation by clicking left button from mouse. Move the left ruler to point where DC link signal level starts to fluctuate. See the DC link voltage level fluctuation, from highest point to lowest point. Move ruler where the motor regulator status changes state. See from the signals which bit was active. In this case bit 5 was active shortly, and then deactivated. Let's look a recap of important things from the service info in this customer problem. Datalogger analysis. Metadata button tells timestamp from fault history. Datalogger analysis. Values before fault are normal operation. Datalogger analysis. Values during the fault. Selected signals visible and zoomed closer. Datalogger regulators inspection. Motor regulator bit 5 was active. For understanding what bit 5 means, this can be seen from drive application manual. Bit 5 corresponds, under voltage controller, from motor regulator status word. Under voltage controller is designed to keep the drive DC link level at operational level. If monitoring this type of behavior, motor output frequency can be seen lower level than normally, as drive is trying to take the energy from the motor side. This slide gives understanding the link between application manual and Datalogger file. This chapter is for conclusion. Conclusion of the fault history and Datalogger files are made. Under voltage controller activated and deactivated. Fluctuation in DC link voltage, but not enough ripple to cause input phase fault, fault code 10. Based on customer information, VACON 100 drive had been retrofitted to replace old different brand drive. Installation inspection shows that input switch is quite old looking, and according to the customer, the input switch was not replaced during the retrofitting of the drive. Therefore, opened input switch cover and noted that when touching input switch shaft, with insulated screwdriver, then input phase fault, fault code 10, actives at VACON 100 drive display. Old switch was replaced and occasionally fault code strips did not appear anymore. Problem solved. Thank you for participation.